In this week's lab, we're going to practice an analytical technique called titration. Titration is a technique where we can take by carefully measuring the volume of a quantity of known concentration, we can calculate the concentration of another material that has unknown concentration but known volume. So basically we're going to do just part A of this lab, where we're going to figure out the concentration of vinegar, the concentration of acetic acid in vinegar rather, by titrating it with sodium hydroxide. In order to do our calculations later on, we're going to need to know the concentration of sodium hydroxide we're using. So please make a note of this concentration, the molarity of sodium hydroxide, labeled here on the bottle. That's going to come in handy when we start trying to do our calculations to figure out our concentration of vinegar. Now, in this lab, we're going to figure out both the molarity of our vinegar, of our acetic acid in vinegar, as well as the percentage mass per volume, or a mass volume percentage. If we want to, get a little spoiler here, you can see that this is actually labeled on the bottle. So you can see that this is actually 5% vinegar, or 5% acetic acid in the vinegar, rather. Okay, so this is a great way to check your work at the end of the lab. When you're doing your calculations, hopefully you should wind up with your answer somewhere in that ballpark for %m/v. Okay. Of course, again, don't forget, we are doing two concentration calculations for our vinegar, both molarity and %m/v. This will help you confirm one of them, hopefully. Okay, and of course, hopefully if you get that one right, then that means that your other calculation for molarity is also correct. In order to carry out these calculations for our titration, I mentioned that since we don't know the concentration of vinegar, and we're trying to find that out, we need to be careful about measuring the volume of vinegar. Okay, that's going to be very important for trusting our calculations. So we need to measure out 5 milliliters of vinegar here, and we're going to be very precise, or rather very accurate with it, by using a pipette and a pipette bulb, which you recall from an earlier lab, allow us to measure volumes very, very precisely and very accurately. Right, so I'm going to start off by pouring some vinegar into a into a beaker here. That'll make it a little bit easier to deal with trying to get a volume of vinegar. Plus, it prevents me from contaminating our stock bottle of vinegar here. So let's pour some into a beaker. We're going to need like 3 trials, need to do 3 trials here, so probably need about 15 mils or so of vinegar. So I think I've probably got, I've definitely got more than enough in there. Okay, so taking our clean, dry pipette, we'll go ahead and add our pipette bulb to that. I'm going to actually take off one of my gloves. If you remember from my earlier video on this, it's hard to adjust the volume with a gloved hand. I find it easier to form a seal on my pipette using my bare thumb. Again, generally you want to wear gloves in lab, but in this case we're not dealing with anything too harsh, or any even our sodium hydroxide for that matter isn't super high concentration. So if I get anything on my hands, I can probably wash it off without damaging my hands in between. Okay, so let's start off by getting our 5 milliliters, or rather go past our volume here. So I'm going to draw up vinegar into my pipette, but not get it into the pipette bulb. So I'll get it right there. Alright, and now I can adjust using my thumb to gradually release the hold I have on the opening of the pipette. I can slowly release some vinegar and try and get the volume marking to that 0 point on the pipette. There we go, and I can clamp that down. So if you want to have a look at it, I don't know if this will be very visible without being too blurry, but you should hopefully be able to see if I can zoom out there. Hopefully you should be able to see the lower meniscus of that marking on the 0 point of the pipette. There we go, hopefully that's less blurry. Okay, so I will then, let's go back down here so you guys can see that. Okay, I'm then going to add my 5 milliliters to an Erlenmeyer flask. So I just lift up my thumb, which I guess you guys can't really see me doing, but lift up my thumb and I will add 5 milliliters of vinegar to my Erlenmeyer flask over here. Okay. Now your directions say that you can add water to this. That will increase the volume, and so sometimes it makes it a little bit easier to see a reading. It's not really necessary to do that. The important thing is that you have enough. You have 5 milliliters of your original stock of vinegar in this Erlenmeyer. Adding water to this, it will dilute the concentration, but since you're basing your calculations off the vinegar that you measured here, that adding that extra water actually doesn't affect your calculations. All right, so you can, if you're doing this lab, you can add water to help increase the volume to make it a little bit easier to see. I personally like using this smaller volume. Since the concentration is a little bit higher, it's sometimes easier to see the color change for me. I'm sure either one doesn't really matter. So I'm going to leave it the way it is. But in case you're reading the directions and are wondering, why I didn't add water to this, that's why. Okay. Now, if we have our 5 milliliters of vinegar in here, we need an indicator that will tell us that the basically our vinegar has been neutralized by the sodium hydroxide we're adding to it. So our indicator for this lab is going to be phenolphthalein. Phenolphthalein is an acid-base indicator that is colorless in acidic solutions. So I'm going to add a couple of drops here, and you'll see that the color does not change. It just stays colorless. The interesting thing about phenolphthalein, though, is that it turns pink in basic environments. So once our vinegar has been neutralized, and basically we have a solution of sodium acetate, which is a basic salt. This solution will turn the indicator pink. All right, so we'll see this bright pink color when our titration is done, when we've reached the endpoint. So I've added a couple of drops of phenolphthalein to this Erlenmeyer flask. You don't really need more than that. A couple drops is sufficient. I'm going to swirl that around, and we've got that ready to start our titration. The other piece of equipment we're going to need for our titration is called a burette. It is this long glass tube. It's open on one end. Well, technically it's open on both ends, but we have a tap called a stopcock at the bottom of it. And essentially we can use that to control the titrant that we allow to run through it. Our titrant for this experiment is the sodium hydroxide I mentioned earlier. So we're going to pour some sodium hydroxide into our burette. We're going to use this little burette funnel over here to help us with that. And basically make a note of the volumes that we're adding through our burette to our vinegar. Okay, so we'll know that we've added enough sodium hydroxide when our phenolphthalein indicator turns pink. And so we'll make a note of the volume of sodium hydroxide that's required to do that. Okay, so I've gone ahead and put my burette funnel over here on top. To make this a little bit easier to deal with, I'm going to lower the burette, so it's easier to pour stuff and go from there. So to release a burette clamp, you just pinch these two, I'm not sure what to call them there, but these two parts of the clamp, and you can just lower this down accordingly. Okay, so I recommend, at least when pouring sodium hydroxide into this, you have this a little bit lower. It's a lot easier to pour than standing on your tippy toes and pouring like that. Probably a lot safer too. So, of course, make sure that the stopcock is closed. I don't know if you guys can see that. There we go. Hopefully that should be visible. But when the tap is perpendicular to the glass tube of your burette, that tells you that this is closed. All right, and so you definitely want to have that closed for obvious reasons when you're pouring sodium hydroxide in there, right? You don't want it to drip through everywhere. So let's go ahead and pour our sodium hydroxide in. I find that given the narrowness of the bore of your burette, if you just pour in your sodium hydroxide with your funnel just sitting here like the way it is, it tends to not allow the air that's in your burette to escape, and so you tend to overflow from the funnel itself. I find, therefore, it's easier to, or probably better, to just lift this up very, very slightly when you're pouring. Okay. Again, this is why it's good to wear gloves when you're doing this. All right. So let's go ahead and pour in our sodium hydroxide. Okay, now a couple of things to note here regarding our setup. I don't know if you can tell from with the webcam all the way back there, but I've basically gone past the zero marking on my burette. Okay, before I do any readings, I want to take off my burette funnel. You don't want to leave this on here during your titration. Sometimes sodium hydroxide sticks to your funnel and it might drip into your burette after you've made a reading, and then, before you make your next reading, you have more sodium hydroxide in there than you think, and that affects your results and your calculations. So we're going to take off our funnel. I'm just going to set it down here on this paper towel. Okay, leave that there for now. Okay. Now, I mentioned that I've gone past the 0 point on my burette, and that's okay for now, because the first time you fill up a burette, there is a little air bubble inside your burette down here. Okay? So we want to get rid of that air bubble before we make our first reading. Okay, so I'm going to get a waste beaker. So here's a beaker I'm just going to use for waste, all right? Let's lift this up so I have room to put the beaker in there. Okay. I'm just going to lower this down a little bit. I don't like to lower my burette too close to any container that's underneath it, just in case anything that splashes back onto the burette might contaminate future results. Any sodium hydroxide that winds up sticking to the outside of the burette might drip into an Erlenmeyer later on when I'm doing my experiment. So be careful of that. So don't have that too far down, maybe just inside the opening of whatever container you're using, in this case a beaker. So I'm just going to open this up and drain out some of my sodium hydroxide, and that should hopefully get this air bubble to disappear.
All right, just so you can get a better view of this, you can see here, hopefully, where I have poured my sodium hydroxide past that 0 marking on my burette. obviously I don't want that there for the actual titration, but I wanted to overshoot that because I want to get rid of the air bubble that's in here right now. Now, you can't really see that air bubble because everything's colorless, but hopefully once I turn this and run some sodium hydroxide through, you'll see that air bubble disappear. There you go. You can see it now looks a little bit different than when we started out there. Okay, as long as we don't run out of sodium hydroxide, this air bubble is now gone, as long as we keep some sodium hydroxide solution in our burette. So this is the only time we actually have to do this step. So whenever I refill my burette from now on, I don't have to go past that 0 mark. In fact, I really shouldn't. Now, if I look at that level, you can see that I'm still past the 0, and that's not good. We want to be able to read our volume, and there are no volume markings past that 0 point, so we want to make sure that we let out sodium hydroxide past that 0 marking. So I'm going to go ahead and do that. Now, I don't have to, you have some students who are super careful here and make sure they get their reading exactly to the 0. I mean, you can, and I guess that makes it easier to subtract since you're just subtracting a 0 to start off with. But to be honest with you, it doesn't really matter. As long as you make careful note of your initial volume, it doesn't really matter what that initial volume is. So I'm just going to run out some sodium hydroxide there. There we go. So I wasn't very careful there about stopping it exactly at the 0. If we look at this very carefully, I'm going to try and put the camera here at eye level, so to speak, so to avoid parallax error, you can see that the reading there is about 0.6 milliliters. Please note that your numbers increase going down your burette. Okay, so each of those large markings is a milliliter each. So so 0, 1, 2, 3, and so on. And each of those small markings, or the small divisions, is 0.1 milliliters. So going down the tube, that's how I figured out my initial reading. Reading that lower meniscus, the bottom point of that curve, I've got 0.6 milliliters. If you're having trouble seeing that, I can add a card here, and you can, hopefully that white card there actually might make this a little bit easier to read. So there we go. I'll try and angle that a little bit better. Okay, so now hopefully you should be able to see that a little bit better. You can see why I got that reading as what I did.
Okay, so now I think we're getting ready to start our first trial for a titration. So I have my Erlenmeyer flask from earlier that had my 5 milliliters of vinegar, and it's got a couple of drops of phenolphthalein in there. Okay. In my burette, I have sodium hydroxide, and I know the concentration of that sodium hydroxide. It's going to be very important for calculations later on. I want to swap out this beaker, now that I've gotten rid of my air bubble. I want to add my Erlenmeyer flask in here. If it's easier to move things out, you could just raise and lower this burette, or you could tilt whatever you're removing or adding and put it in like that. Okay. Again, you don't want your burette too far down. I mentioned you don't want any splashback onto your burette. It's just going to contaminate your burette and probably influence further trials, which we don't want. So I'm going to make sure that I raise my burette a little bit higher. I want this in such a way that the tip of my burette is not above the opening of my Erlenmeyer flask. It's definitely inside the flask, but at the same time I don't want it all the way down too far. Okay, so here's just inside the opening of my Erlenmeyer. Okay, so here's a closer view of what I was mentioning just now. You can see that my the tip of my burette here is just inside the opening of my Erlenmeyer flask. So that flask isn't really going anywhere. And so I don't have to worry about any drops of sodium hydroxide falling outside of the flask, okay, which is kind of important. Another thing I'm going to do to help make this a little bit easier on us is I'm going to add a piece of paper here and I'm going to put it underneath my Erlenmeyer flask. It's going to make it a little bit easier to see the color change we're looking for. Remember, we're looking for that sort of pink color that's going to tell us that all of our vinegar has been neutralized by the sodium hydroxide. Okay. All right. So let's go ahead and add, start doing our titration. So I'm going to lift this up so you can see how I do this. There we go. All right. So typically, the way you handle a titration is if you're, this is set up so that if you're right-handed, you've got the readings over here in front of you, of course. You use your dominant hand, and in this case I'm right-handed, to control the stopcock. That way I have like a little bit more control, for turning it on and off. You use your less dominant hand, so in this case my left hand, to swirl this flask while the experiment's going on. Okay. Here, let's bend that a little bit so that way you guys can see that color against this Erlenmeyer flask. Okay, so there we go. Should make that a little bit easier to see. Okay. All right, let's get started. Now, as I start running some sodium hydroxide in there, you can actually already start to see some pink color showing up where the sodium hydroxide hits the solution. Okay, but now watch what happens when I swirl this. That pink color immediately disappears. Now, the reason for this is that those localized drops of sodium hydroxide hitting that solution are neutralizing the vinegar, the acetic acid, in those localized regions. And that's where you're seeing that pink color. However, when I swirl the flask, the surrounding vinegar that wasn't neutralized is coming in and using up that sodium hydroxide. So you could think of this in terms of a limiting reactant sort of point of view. Right now, we have an excess of vinegar in there. Okay, that pink color is only going to stay when sodium hydroxide has used up all of our vinegar, and sodium hydroxide now is our excess. Okay, we want the vinegar to be our limiting reactant here. Okay, so we're going to keep on adding sodium hydroxide. So as we add sodium hydroxide, okay, so I'm just going to add this and keep on running this. You can see that as it continues to keep on swirling this, that pink color is disappearing relatively quickly. But you can see that I don't know if you noticed that just now I stopped this just so that I have some time to react here. That pink color started staying a little bit longer no matter how much I was swirling it, right? That's telling me that I'm getting closer to the end point, so I probably want to be a little careful here, okay? I was adding a whole bunch of sodium hydroxide at once. You can set this up, if you turn the stopcock just slightly, okay? Basically, if the stopcock is completely parallel to the burette, that means it's fully open, right? But if we turn this slightly, so let's see if I can do this here. There we go, very gently there. Now I've set it up so that it's releasing a drop at a time, okay? So now I can be a little bit more careful about the sodium hydroxide that I'm adding. If you want to see that from a different angle. You can see, though, we're still quite far from the endpoint. The fact that just a little bit of swirling causes that pink color to disappear pretty much immediately kind of tells you that we're probably not by the endpoint. This first trial is going to be a little bit rough because we don't know where the endpoint actually is. All right, we're probably going to overshoot this if I'm not careful, and that's okay. That's why we're doing 3 trials. We're going to take the 2 trials that best agree, that seem the most probably the most accurate, which are usually the second and third trial. So even if we aren't completely accurate on this one, that's okay. All right. So I'm going to go ahead and set this down and just increase our flow rate here, just so that we don't spend forever doing this first titration. Because again, that's the whole idea of doing that first titration a little bit rougher, so that you get an idea of roughly where to aim for. There we go. All right, so you can see now that that pink color is not disappearing no matter how much I swirl this and stir it. Okay, so I've clearly passed the endpoint here. All right, so we're going to make a note now of our final volume. Okay, so I'll put that up here, and hopefully you guys can read that. I'll take another picture with my phone, hopefully, and that'll give you another accurate, or another hopefully less blurry or a little bit easier to read picture there. As I mentioned, we've kind of overshot the endpoint here, right? This pink color is staying, but I don't know at what point this pink color showed up first, right? Was it the drop right before this? Was it like a couple of drops before this? I'm not sure, because we didn't know where the endpoint was, so we kind of overshot there. Okay, but now what we do, now we know roughly where that endpoint's going to show up, we can be a little bit more careful in our second and third trials and try and really nail down the exact drop that will cause this solution to reach its endpoint. So the perfect endpoint is where this solution is colorless. We add one more drop and the pink color stays. Okay, that's the perfect endpoint. That's what we're going to shoot for on our second and third trial. Okay, so off camera, I went ahead and added 5 more mils of vinegar to a fresh Erlenmeyer flask. All right. Of course, don't forget we have to add 2 drops of our phenolphthalein indicator to this Erlenmeyer flask. So 1, 2. That, by the way, is the most common problem students run into on this lab. A lot of times students will forget the drops of phenolphthalein indicator, and they add all of their sodium hydroxide, wondering wait, why am I not reaching the end point? And so that's, if you're ever doing this in real life and you're wondering why that happens, always ask yourself, did I add the indicator? Okay, don't forget the indicator. All right, so we have our Erlenmeyer flask with our 5 milliliters of vinegar and indicator. I'm going to add that to underneath our burette. Since we used less than half of our 50 mils of sodium hydroxide that was in this burette, I'm not going to bother topping off my burette at this point. I'm just going to use the same volume that we stopped at. We're going to start at the same volume we stopped at with our previous trial. Okay, so make a note of that for your initial reading for trial number 2. Okay, now I mentioned earlier that because that first trial is a little rough, its purpose is not so much necessarily to give us a right answer, but to tell us where do we aim our next couple of trials. All right, so you saw that I added roughly about 18 milliliters of vinegar. Okay, so I'm going to make sure that I'm going to add about, 16 milliliters or so. And I can add that really quickly without really paying attention. And at that point, I'm going to start being very careful about how much sodium hydroxide I add. Okay, so let's keep that in mind for this trial. So right now we're at about 18 and a half, reading it about 18 and a half. So if I add 16 to that, that's what, 34 and a half? So let's just run this down to 34. So here, actually, I can just show you that. Okay, so we're starting off at that initial, roughly about 18 and a half. We're going to run this down to somewhere about here, to somewhere in that ballpark, and we'll go from there. Okay. There we know that we definitely added the phenolphthalein. That's always a good sign. Okay. Yeah, there we go. So we know I've gone to about, I think that's about 34 and a half or so. Again, we don't have to be super, accurate here. just because we're not done yet. You can see that when I swirl my Erlenmeyer flask, it still stays colorless, which tells me that I have not finished neutralizing my sodium hydroxide, or my vinegar yet with my sodium hydroxide. So let's continue adding some sodium hydroxide, but let's be very careful here about how much we're adding. So I'm going to add, again, probably about a drop at a time. Whoops, maybe slow that down a little bit. Okay. And again, you can see how quickly the pink color disappears as I'm swirling here. Okay. I don't know if you guys can, if I pull this back a little bit, you can see me holding onto, I've got my hand ready to stop the flow of sodium hydroxide as soon as I realize the endpoint's close. So. Yeah, that pink color is staying longer, so that's okay. So as I turn this, you can see that pink color has kind of disappeared. Oops. And actually, it looks like there was one more drop that fell as I got done. And you can see that pink color is not going anywhere. So we have reached the end point, and this is probably a good end point. I think that pink color it was colorless when I was swirling this, and you can see that we have this nice light pink color that's staying, no matter what, even with swirling this flask, that pink color is staying. Okay, you can see it's that's probably a good endpoint then. So let's make a note of that volume, our final volume here. Oops. So hopefully that should show up. But again, I'll take a picture with my phone, so hopefully it'll be a little bit, easier to read. All right, so again, off camera, I've added 5 milliliters of vinegar to my Erlenmeyer flask over here. Okay, I've also kind of topped off my burette. Now, when I say topped off, I didn't fill it all the way to the top. As you probably noticed in our first 2 trials, we used less than 20 milliliters of sodium hydroxide from our burette. So rather than fill this all the way to the top and then have a whole bunch of wasted sodium hydroxide at the end of this lab, I just filled this up past the 30 milliliter mark. Okay, so then I know that I have at least 20 milliliters in my 50 milliliter burette. So again, if you want to make a note of that initial volume now, okay, that initial volume is, let's see, I'll try and get a, yeah, sorry, I'm trying to organize this here. No, so basically, hopefully you should see that, and I'll try to get that at avoiding parallax error. And of course, I'll include a picture from my phone that might make that a little bit easier to read. Okay, so let's. Oops, nearly made the cardinal mistake of forgetting to add my phenolphthalein indicator. That would make this last trial very rough indeed. 1, 2. Add a couple of drops in there. Okay, that's much better. Let's roll it up. Okay, so last trial. We want to try and nail down what our volume's going to be, and so let's go ahead and start running about about 16 milliliters or so, just to go from there. Okay, so if we started at about 27 milliliters, if we add 16 to that, that should get down to about 43. So let's run this down to about the 43 mark here. Okay, so again, it doesn't have to be exactly 43, but you can see, obviously, I've got this horrible pink color that's kind of scary because you always second guess yourself and think like, oh, did I overshoot my endpoint? But you can see how a little gentle swirling caused that to disappear. So, phew, big sigh of relief, we haven't hit our endpoint yet. So, let's go ahead and add some phenolphthalein, or add our sodium hydroxide dropwise, very gently. And keep an eye out for that endpoint. So as soon as I see that endpoint, I'm going to clamp this shut. Now, as soon as I think that that pink color is lasting a little too long, clamp that shut. So you can see that pink color is definitely lasting a bit. So again, it stayed clear so far, so that's a good sign, or colorless, I should say. It's colorless, so that tells me I haven't quite reached the endpoint yet. Let's add one more drop and see what happens. Actually, I don't know if you can tell, but there's like a little drop clinging on there. So hopefully that comes loose. Oh, there we go. I think that drop has come down, and it's still colorless, so let's add one more drop and let's see what happens. Very gently, wait for it. There we go, let's see what happens. Nope, not the end point. But we're definitely getting close, so let's be very careful at this point here. I'm just going to add a drop at a time just to be on the safe side here. Again, we're getting pretty close. One more drop. Oh, there we go. So that's what I meant, like when you add one more drop and that pink color stays, you know. That's the perfect endpoint right there. Okay? So let's again make a note of that that final volume. So I'm trying to coordinate a webcam here and try and get that's legible. There we go. Again, I'll take a picture and hopefully that'll be a little bit more visible. And there you have it. We've taken 3 trials of our vinegar being neutralized by sodium hydroxide in our burette. If you take the initial reading from your burette and subtract it from your final reading, that tells you how much sodium hydroxide you added to your vinegar. Okay. Now, we did 3 trials, so you want to take the average of those 3 volume readings. Okay. That first trial, even though it was a little rough compared to the other 2, we didn't know where the endpoint was. You'll probably find that it actually was relatively accurate. The 3 trials we took are very similar to each other. Okay, so even though we didn't know where the endpoint was, I think I was careful enough in that first trial that I think you can trust that first trial and include it in your average. Okay, I mean you could also throw that one out and just use the like trial 2 and 3 for your average, and that's fine. But like I said, I think that if you keep that first trial like the instructions say you should, you'll still get a relatively similar answer. Okay, now that volume of sodium hydroxide, that average volume, that's going to help us figure out the moles of sodium hydroxide. Remember, we found the molarity of sodium hydroxide because it was written on the bottle. And so using the volume, or the average volume that you're going to take, and this molarity, you can solve for the moles of sodium hydroxide. Now remember, sodium hydroxide and acetic acid react in a 1-to-1 ratio. So knowing that, you should be able to figure out the moles of acetic acid that were present in your 5 milliliters of vinegar. Okay. Again, because we were very, very careful to measure exactly 5 milliliters using a pipette. So if you know the moles of acetic acid, and you know the volume of acetic acid, or your vinegar, well, you then can figure out the molarity accordingly. All right? in addition to this, don't forget you also want to calculate your percentage mass per volume. So if you go back a step and you've got the moles of your acetic acid, you can figure out how many grams that would weigh using the molar mass of acetic acid. Divide that by your volume and figure out that as a percentage, and you've got the percent m/v. And of course, this is a great way to make sure that you're doing your calculations correctly, because if you recall, it was written on the back of the bottle. So if you get an answer close to the one listed on your bottle, you know that you've probably done your calculations correctly. Okay, and of course, your lab manual does walk you through these calculations as well. So please refer to those if you get stuck. And as always, if you have any questions on this, just let me know, or let your instructor know if you're not one of my students, and I'm sure we'll be happy to help you out. All right, so normally this is where we'd stop, and there's a second part to this lab involving a back titration of an antacid. We typically skip that part just because when we're in person, we use the second half of lab to let everyone check out of their lab drawers. So I'm not going to do that part of the lab here. We're just going to have part A, and so once you've done that, hopefully you're done. All right, so with, again, we'll leave that up to your instructor. They might have you do the calculations for part B. I'll leave it up to individual instructors to see how they want to handle this. That being said, as always, if you have any questions, let me know. And that's it for lab. So thanks once again for joining us for this semester, and go Timberwolves!